Hello students, this is a continuation of our review of arrays. In the previous video, we talked about what are arrays, the concept of arrays, the need for arrays, and also how to declare an array, how to traverse an array, what is the meaning of indexing into array using the zero indexing, and also how to pass an array into a parameter, and how to appreciate the fact that arrays are passed by reference. And so whatever happens to the array inside the method gets reflected outside the function as well. And here in this video, we will go over, as is here in the blurb, how to read into an array of string from a file and how to fill the array. While doing so, right, we put it in a repetition structure. We're looping over and trying to read all the elements inside this file into the array. But we have to keep size at the back of our mind to make sure that we do not overfill the array. There is also a possibility that we have an array of a certain size, but we do not have at that point enough information in that file to fill the array. So these are a couple of things that we will go over and how you can use this information in your coding going forward. And also, how can we read a line of information called a record into a string array, and how can we process that, and what are the tools that C++ offers, for example iStringStream, to help us process this line of information. So as you can see here, I've got this data file called trees, and it's got just names of trees here, and you can, if you see the line numbers, you will notice that I've got 8 trees here. So let's get into our main program. And here in our main program, I have declared in an array called trees, and it's the size of this array is max, and I've declared max to be a constant of 10 units. So we now have the capacity to store 10 trees into this string array. So let's do that. And in order to read from a file, I'm going to need include fstream to read from the file. I also, as you know, need a file variable. So I'm going to say in file. I'm going to say ifstream and give a file variable, and let's call it in file for input file, and connect this string variable, which is called in file, to the name of the file, which is trees.txt. We have done this before, but and then we know that if we are able to open this file successfully, if infile.fail, i.e. we were not able to open this successfully, then what we are going to do is we are going to just simply say file open error. Nothing more can be done. Therefore, we would need to exit this program. And else is where everything else happens. And here we go to populate from the file. So now I can, if I was able to open the file, now I can declare my array of string, in which I can store maximum 10 trees. And now I start to populate. What do I do for I is equal to 0, I less than max? Now let's make some errors as we go, and then we will kind of rectify our mistakes to learn how to do this. So 10 times what I'm going to do is from in file, I will populate into trees I. So what am I doing here? What I'm doing here is the 0th, when I is equal to 0, the very first tree, which is oak, should get placed into trees of 0, and so on. But now let's try to have a file called trees.txt. We have 8 trees in this file, and what I'm doing here is I would like to declare max to be equal to 10. And when I run this, I can see that it has displayed all the 8 trees. So what it has done here, what my program has done is if the file was successfully opened, then from 0 to up until 9, go ahead and read from the file into that particular element of the array. So trees is going to go, so this part of the code is going to go trees 0, trees 1, trees 2, all the way up to trees 9, and go in a loop and then fill the element from here into the array. Now, as you can see that I have, my array has a capacity of 10, but I've only filled 8. This is something to watch out for, that if you're trying to read more values than are present in the file, some of the IDEs may end up crashing your program, or you may end up having an array in which some junk elements are stored. Right here we see that we don't see any junk here. We just see blank spaces, right? So we're just going to see blank spaces after Aspen. There are likely spaces, 2 spaces. We don't see them, but they're there. So in order to circumvent this problem of having a larger array and trying to store elements in the array and maybe not filling the array to capacity, we can, instead of going for a for loop, we can go in for a while loop and say, how about we just print, so here I'm going to, let me call this count. And this will be useful because then I will know exactly how in my program how many trees there were inside my data file. So I'm going to increment the count here. So initialize count is equal to 0, and then while I've not reached end of file, so I will keep inserting from the file via the file variable into the array element. So this I should also change to count. And when I complete this, this loop is only going to execute 8 times because there's only 8 elements. The for loop executed 10 times because I forcibly drove it to go from 0 to 9. But this one is going to stop when the file runs out of data. So let's run this and see if this works. Executed 8 times. And it has displayed the trees. So it looks very similar to what we did before using the for loop, but there is a difference. Now I have executed the loop only 8 times. I also have a count of how many trees there actually exist, and that will be useful for me when I want to process that array. I would like to do one more thing. What about if I added some more trees here, XXX, YYY, and then AAA, and BBB. So now in my file, I have 12, and I have max defined to be equal to 10. So when I run this, this gives me a segmentation fault. So this is one thing that we need to be careful when we're reading from files, that if we provide more data and we end up pulling out the data from the file using a while loop and we read until the end of file, then we have to be careful that we don't overrun the array, we do not exceed the capacity of the array, so that we don't run into program crashing like that. We can add one more condition, of course, here and say, and count is less than max, right? So that we're reading up to capacity and we're neglecting all of those trees that, that cannot fit into the array. So let's see if this works. And you see, as you can see here, XXX and YYY have been picked up, but the other 2 have been left alone. So these are kind of tips and tricks for you to build conditions inside your while loops, to do reading from files into arrays, so that you can use these going forward in your program. Now let's come back to this problem and say, what if, so the other thing we can also do here is, if we have some intelligence about how many there are, then we can change this instead of max and say, I only have count. So I only have 5 or only have 6. So please don't even try to print more, because the array could be empty. And it's not a good thing to print out of the empty part of the array. It could be filled with a junk memory address, and that will end up crashing our program. So these are safety measures for us to keep in mind when we are dealing with an unknown number of data elements. But of course, we know that the maximum is going to be clearly defined for us. That's the one thing about arrays, that we have to initially commit to a maximum size, knowing that either we can fill the array to capacity or we may have less. And if this number is very, very large, for example, if max is equal to 100,000, then definitely it's worth our while to have something like count, because you could end up just filling 5 when you wouldn't want to process the entire array and get into a whole bunch of problems if you only had 5 data points and that's all you needed to process. So now let's move on to part 2 of this. What I'd like to do is, here I would like to add some numbers. And then I will remove this because I'd like to go back to our 8. And these are the ages of the trees. So now on each line, what I have is, I have the name of the tree, and then I also have the age of the tree. And I would think, oh, I'm going to read a string. Why would it not just go ahead and print the name and the age for each tree? But look what happens here. So now it just so happens that this has picked up oak, pine, cedar, spruce, and sassafras. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It's actually gone ahead and picked up, because the max was 10 and we wanted to read up to max, it has picked up 10 items, not realizing that the first one is the name of the tree, the second one is the age. What we actually wanted the name and the age to come together, but it has considered this to be the first tree. Let me just change that. It has considered this to be the first tree, this to be the second tree, this to be the third tree, and so on. And it has considered this to be the 10th tree, not knowing that this is a number. It's read this integer as a string, and that is important to know. If you read something into a string variable, it's actually going to read an integer into a string. But there's another problem, is that we actually meant to read all of this. We didn't mean to read this into trees. We actually want this to be, the age of the tree. So how to solve this problem? So the way to solve this problem is, and why does this problem arise? This problem arises because when you do infile is going to read one token, and it's going to stop reading the token when it sees the white space, which is the blank space. It's going to say, this is my first token and this is my second token, not realizing that there is a new line character here, and our intention was to read all the way a string all the way up until the new line. But the way we are reading here is going to be restricted to what we just saw. So we have to change this then and say, instead of infile, reading from infile this way, we can use another C++ function called getline. It says, get the whole line up until the new line character, which is hidden, but it's there in the file, and put that whole thing into trees count. So now let's see what happens. Now, as you can see, it's actually read all 8. I'm going to now put a end line here so you can actually confirm for yourself that there are 8. And now it has actually read 8. And now we see it has read the entire string. However, everything looks good, except that if we wanted for some reason to add up the ages of all the trees, the question is, how are we going to get our hands into, now each element of the array looks like this. This is a whole string. How are we going to get our hands only on the age or only on the name of the tree? Here's where the iStringStream operator is very helpful. And there is another video. The next video goes into detail about how to use the iStringStream operator, but I will just go into that here for a little bit and say, this is iStringStream, which allows us to process strings. In order to use iStringStream, we have to include the StringStream library. So in order to do that, we have to include the StringStream library, and we can do that by including SStream. And here, it's basically a library for processing strings. So what I can do here is I can create a stream that processes a single line. And I'm going to call this line, and I can initialize that. So here let me just put this whole thing in a loop for integer I. Let's do this. Now I can use a for loop because I know exactly how many items I have in my array. And now I can say, put trees of I into line. And then what I'm going to do is I would like to integer ages equal to 0. And now you see how beautifully iStringStream works. What we can do is we can say, from the line, you can throw away standard string name of tree and put that into name of tree, but put the next item into age. So, and I can create another one, total ages of the trees equal to 0. And then I can say total ages equals total ages plus the age that I just read. Change this to age, right? And when I'm done with this, I can just print out total ages of the trees is, and here I've got total ages. There we go. So basically what I have done here is I take this whole thing, goes into the 0th element, this goes into the first element, this goes into the second element of the tree, and so on up to the 7th. So the trees array now is an array containing this entire line. In turn, inside this loop, I pick up the line from the tree and put it into an object called line, which comes from the StringStream library. So line, in the first time, the line contains oak and 99. This is what line contains. And what I can do is I can use the same extraction operators to extract from the line. The first thing I extract is the name of the tree and put it in name of tree. Then I go to extract the second part of this. And the second part of it is the age. And know that this is actually declared as an integer, even though this whole line is read as a string, the iStringStream allows me to read an integer, pull out something that looks like a string, but convert it into an integer. And this conversion is done by iStringStream, which is great. So store the age as an integer, pull it out of the line, pull the string 99 out of the line, convert it into the integer 99, and store it into age. And then I keep adding this up. So line by line by line, I'm going to take this, each line or each element of the array, store it in the StringStream variable, and then process it by extracting the fields and then adding the ages. This is the kind of stuff that you're going to be doing in your application as well.